All right, so we're going to continue on looking at the SDL tutorial, more specifically around using nim as opposed to C++. So again, this is based on Lazy Food Productions tutorial, and in this one we're up to now part 5. So part 5 is around optimizing the surface loading and stretching to a window, and they install a whole bunch of libraries, and of course again I'm not going to go through it. This is really just to show you how you can convert the code from C++ to nim. Alright, and I have done a number of lessons ahead, but I'm going to try to do this all from scratch without looking at the solution, if you like, just to revise. Now let's firstly have a look at what the expected output is, and 0.5, I think I've already compiled it, so if I run, the expected output is something like this. So that's the goal, and again we're just going to have a look at some of the previous ones as a template, which I've done here. So we just use key press, and we're just going to start loading things. So well, firstly, we don't have key press in here. We do have the screen width and height, and we initialize these kind of variables. So we have G window, G surface, and G stretch surface. Right. And it needs load media close, which is the same as before, roughly. So firstly, let's look at load media. So load media, did I have load surface? Yeah, they do. So load media, it is a bool, and what do? We load stretching surface. So we do a G stretch surface is equal to load surface or stretch.bmp. Alright. And then if I go and look at the load surface, let's have a look at load surface. What is it? So this is a final output, which in nim would be result. We have load BMP as here, the loaded surface. This time we actually want to call something else. So right, let's call this the loaded surface, and this is a surface pointer, right? Let's firstly load the surface. And then what we want to do after it's loaded is we want to convert the surface using this. So this is actually a result equals convert surface, right? And we have the loaded surface, G screen surface, and let's have a look. Dot format. And 0. I need to know, yeah, expect cint, so let's just make it a cint. Alright, and that's all we need to do for the load surface. And then let's go to, and now I think we're ready to go have a look at close. So close is, what do? We call free surface on the G stretched surface, and then we just destroy the window. Okay, so that's fairly straightforward. And now let's have a look at main. So main should be pretty easy as well. We just want to load current surface. So we want to this is just a bit that's new. Let's just close all of this. So we have a rect thing, so let's call that stretched rect is a rectangle, and then this is equal to rectangle that is 0.cint, 0.cint, screen width and screen height. And then what we want to do is we want to call the G stretched surface nil screen surface and the rectangle. That should be it, right? And then we just run it, and this should successfully type mismatch. What is it expecting? I think this is correct. Well, let's just run it and see what happens. Oh no, it's wrong. Okay, there we go. So then this becomes a pointer. Alright, so let's have a go to compare. So we want to run nim compile, and we also run it straight after. Hopefully this works. Okay, so something has gone wrong because we just get a black screen. So let's have a look at, so I'm going to call this tutorial 5. It's because we haven't referenced the image in the correct place. Alright. Okay, so we're getting closer here. We've downloaded the thing, but it hasn't stretched the window. So let's have a look at what we've done wrong. And it's probably because we haven't done, because this is supposed to be scaled. Alright, well, that was rather careless. So finally, if I run this, we should get the scaled version, and there we have it. So this shows you how we can do this for tutorial 5. Okay. So now that since we've done that, let's jump over to tutorial 6. Okay, and hopefully this will work as expected. Let's go and jump straight into tutorial 6. We are going to close this, of course. Let's firstly have a look at what tutorial 6 expects. So we're going to start loading PNG files, which uses the SDL image extensions. I'm not going to go into detail on how to install it. You can figure it out yourself, as again, because the purpose of these streams is to look at the nim conversion, not to go through the tutorial in depth. And these extensions are supported within the nim version of the SDL2. So what we're going to do now is, well, we're going to go ahead and start loading it. Okay, so what did I call the old one? I called it image extension. So I'm just going to call this one image.nim, and let's open image.nim up. Okay, so this is blank, and I'm going to put again this one on this screen. Okay, let's see if I can remember how to do this. So again, let's just copy this over, and let's have a read of the original source code. So we can see that they import SDL image. I think that's the import is this image, and I'm just going to give it an alias. I believe that's the correct one. I'm going to have a quick sneak peek. You can look this up yourself, and yeah, that does look correct. So now let's go and have a look at what's the next thing we're going to do. I realized that I have been using like init everything, but that's not necessarily what is used in general. So I'm going to have a quick double check that, yeah, so they use video, which would be init video. So let's just, for consistency, also make sure that we do that. And let's just load the initial constants, which are the same. So we have screen width, screen height. We have a window, G window, G screen surface, and the PNG surface. So let's change this. And this is again a surface pointer window, and there is a function called load surface, which we'll get to. So let's start off with this particular proc. All right, so we start off by, I think all of this is the same. Oh yes, there is this new flag, which I am again going to cheat because it's just a constant that users have to look up in the source code. So here we go. I've put it here, but I think that this is actually bad practice. So I have no idea what the correct practice is. So we are just going to do things as they fly. Okay, and then what was the next line? All right, and then we do the G window. So this is initialize PNG loading, and then we create the window surface, which is great. Then what's the next step after this? Next step after this is to look at the media loading. And let's have a quick look. Load media. So we load surface and it's just loaded PNG. And that's loaded PNG. But now we need to change our load surface proc, right? So our load surface proc will be a bit different, and I'm going to have a quick look at what the method is. So it's just exactly this, just a one-liner. So let's have a look at what load surface does. So they have the final optimized image, load image at a specific path. So loaded surface is a load surface, and it's just called image load. So we'll do that. And then convert surface is the result. So I think that's very much the same. Okay, so that should be the same. Then let's go and have a look at, so we have load media, surface, load media. Okay, load media goes the PNG surface to be load surface, loaded, and then return success. Okay, so that looks like that works. Now let's have a look at close. Close does the free surface on, well, the PNG surface instead, and then destroys window. Okay, that is the same as well. I think probably missing like okay, now we have to quit both. We've run the load surface already, and now we go straight to main. So main, we initialize loaded media, and then again we're going to have the run game loop. It's on here. I think it's this quit event as per this bit. And then finally we just apply the image. So they use blitz surface this time, so we'll go back to blitz surface. There's no stretch rectangle, and we have the surface, nil screen surface, and the last object, because there's no stretch rectangle, is this nil. And then we close and we're done. So this is all there is. What we introduced in this particular tutorial is this particular import and loading different types of files as per here. And that's really it. So this one's quite straightforward. Right, so let's have a go and just double check that that works as we intend. And there we have it. It's loaded correctly. I'm going to make sure it says tutorial 6. Alright, and then we will move on to number 7. Okay. Oh, I don't want to close it, sorry. Okay, so let's go to number 7. So this one is to do with textures. Let's have a look at what we're trying to achieve. Rendering texture. So again, let's have a look at what the source code is doing and what we're introducing in this particular lesson. Look at that lovely lag. Alright. Close this window. So I call it textures.nim, so let's create something called texture.nim, alright, without ds. Again, let's do the same thing. Let's just copy this file and paste it in this empty one. And let's have a look at the differences and go ahead and read the code. Alright, so let's just go from the top again. Again, you can see that we use this particular library, deal with different file types. And same screen dimensions. I'm going to use the window pointer, grender, which is now the render pointer. So that's different. Render pointer, and then texture pointer. We have load texture now, which is new. In the initialization, we will use the set hint. So I'm going to also copy and paste from what I looked up before. So I believe, hang on, initialize, and the first thing it does is it uses the set texture filtering to linear. So I think it is set hint, and this is like quality of 1. Okay. I think that's how you do it, or not. What is it complaining about? Discard. Alright, then we create window. And then we create the renderer. All right. accelerated. Okay, so that will create the renderer. Okay. And then the next thing we want to do is initialize renderer color. Set draw color, gRenderer, and this will be, I think this is like uint8255. 1, 2, 3, 4. Okay. Set color, then we initialize PNG loading as we do, and then we end. So there's no need for that get surface window. Alright, so that's the initialization. Next thing, load media. So this is actually a load texture now. And this returns a texture pointer. I'll deal with that later. So load media, we call load texture of the texture.png. Okay, and this is a G texture. It's on line 95. So then if we go to the next one, so that should be done. If we go to close, we can firstly destroy G texture, and then destroy gRenderer, destroy gWindow, and then we quit. Okay, so that's pretty straightforward. And now finally we go back to load texture, which I have here. So the final texture is new texture, so we want a texture pointer, so we can ignore that line for now. We want the loaded surface, which we have here. Again, this is just the load of the image path, and when this is done, we want the result to be the, what's this, create texture from surface, right? From surface. And arguments of this is gRenderer and the loaded surface. Okay. And then once that is done, we want to free the surface. Loaded surface. Okay. That's how we load the texture. Once you've done that, I think that's it. We can go straight to the main loop and we can figure out how to pull this all together. So the first thing we do in the main events loop, or main run game loop, is we want to clear the renderer, clear screen. And we want to render the texture to screen. Copy gRenderer, gTexture, nil and nil. Finally update the screen. I think this is present. Close and discard. So what's these red things here? So render clear and render copy don't exist. I'm just going to cheat and have a look at what the actual thing is. So is this present and copy? Copy, and this is probably this clear. Okay. Now let's try running this and hopefully everything works fine. and it looks like it's worked correctly. Let's so I've got it 6. Let's make sure I didn't cheat. It should be called number 7 now. There we go, tutorial 7. So there we have it. That's how we can also do the 7th chapter of the SDL tutorial. Right, let's keep on going. Now, the next one is we're going to look at the 8th chapter. The 8th chapter is geometry, so let's have a quick look. So in this one, we're just drawing rectangles on the screen. So if we run this, we can see that this is, I have a print on, which doesn't help. And yeah, we're just printing lines and squares and dots on the screen. So I'm actually going to, so I am going to create a new one called rect.nim. I think this one might be a bit more difficult, and I might need to actually have a look at some of the reference material. But it's not too hard. So again, let's just copy the previous one, even though I think a lot of it isn't relevant anymore. Okay, and let's go from the top. So the constants, so that's still the same. So window and renderer, that's the same. There's no texture here. I don't think we load any textures. I think load textures and load media is actually redundant, so I'm just going to delete it. Nothing to load, and close is destroy the renderer and quit, right? So we ignore that. In main, well, there's no media to load anyway, so we can delete that, and the bulk of the logic will be in this loop. Okay. So firstly, we need to clear the screen. Set draw color, right? Renderer, and we need to set the color to be okay. So this will just make the whole screen white. Done it correctly. Oh. Then we want to render a red filled rectangle. I don't know why they call it a quad. So var fill rect of a rectangle. So this, I'm just going to copy all of this. Actually, this is pretty straightforward. And we need to cast all of these inputs as the correct type. We need to set the render, set draw color, okay. And 8 of 255. We want to make it red, so that's 100%. That's 0. it transparent. And then finally, let's expected one of what have I done wrong? It does look a bit off anyway, so let's make this not sure. Anyway, let's run fill rect. For the rectangle, okay, and then that should be it. Then we filled up the red rectangle. We can do a green outline of a rectangle. So we do something similar when we define what the rectangle is. Of course, this is now called a outline rect because we don't want something that's filled. We want screen width on 6. Screen width on 6. Times 2 on 3, and the last one is times 2 on 3. Right, and we want to make this green, so this is 0. Alright, and we want to select the outline rectangle. The next thing we want to do is we want to draw a blue horizontal line. Blue horizontal line. Okay, so RGB, so red, green. So green is 0, blue is the highest value, and then we want to do a draw line. Zero. Screen height on 2 dot set. Screen width. Okay. And then lastly, we want to draw a vertical line of yellow dots. Okay, so we want to set the color to be yellow first. Alright, and now we have this for loop for I in count up 0 screen height -1 increment by 4. So this will be a draw point, G renderer, screen width on 2, and then let's clean up or update the screen. Required type of y cint, constant int, expression I is type int. So of course, let's change this. Okay, so we have something, but this isn't what we wanted. So the immediate reason is because I used filled int instead of the draw rect. So maybe that just solves it for us. Okay, and there we have it. We have our image with our rectangle as we wanted. So let's just show that this works. So we've set this screen to white. Why don't we choose a different color? Why not some kind of gray? Let's just see what happens when we do this. Okay, and we can see that we've changed the background. So there we have it. That's the 8th chapter within this tutorial done. And continuing on, we have the number 9 tutorial. So let's have a look at what that one involves. So this is looking at a viewpoint. Viewpoints are quite important because imagine if you are rendering some kind of heads-up display within a computer game. You want to use viewpoints or something similar in order to control the different facets that you're interested in. So let's have a quick look at how this would work in nim. So I think the example that they use is actually quite straightforward. So let's have a look here. Run it. There we go. We have a viewpoint. They just split the screen in half here. So they have 1, 2, and 3 bits where they've just stretched the image over each of the different viewports. So let's just close this and let's go up. Let's touch. Hang on. What did I call the original file? Viewports. So we're going to call it. We'll just call it view.nim, and let's have a go at what this would look like. Number 9 view.nim. Again, we're just going to copy what we've done before, just as a template, a starting point. We don't want to retype everything. And let's have a look at the source code. Okay, so let's go again, top to bottom. We have the screen width and screen height. These are constant. We have the window renderer, and now we have the texture. And this is a texture pointer. Right, and we have a load texture procedure that we need. I think that will be different. I might need to look at an older version. Let's see how this is initialized. Maybe I'm going to hide the minimap. Whoops. Okay, so let's see how this is initialized. Again, they use the hint, which we have. They create a window, and then they create the renderer. Then they set the render draw color, which I've done here, set the flags, and load the PNG loading. Okay, so that's the same. Let's go to close. We go destroy texture, destroy renderer, destroy window, and quit. So that's fairly straightforward. And then off the back of this, I just jump straight to the main, which obviously is not true anymore. So let's go and have a look at the texture file that we had, and we're just going to copy the texture and load media. Okay, so let's have a look at load media first. So load media loads texture, called something called viewport. And the next thing we want to do is we want to actually run the load texture. So let's have a look at what load texture looks like. Should be fairly more or less the same, right? So we have load surface. There's a surface pointer which runs load on the path, and then we call it the free on the load surface. The load media, right? So load media just loads that, so that does nothing as well. So the most important thing is to look at the main function. So the main function, there's a lot going on here, right? So let's have a look. Okay, so the first thing is we initialize, then we load media. I don't know what's going on with my formatting, right? Oh. What's going on here? Previous declaration. Okay, they're the same. So we load the media, and then we go through the game loop. The first thing we want to do is we want to create a white screen. So I'm going to make this I want to do clear, and now we need to handle the viewports. So let's have a look at how we can do that. I'm going to delete left corner viewpoint. Right, so let's just call this the same way. There's no point overthinking this. .c screen height on 2.c int as well. So I'm just copying lines 191 to 194, and then we need to set viewport, and that will be grenderer and the top left viewport. The next thing we want to do is we want to set this to screen. Nil and nil. And then we do the same thing for the top right viewport. So this is more or less the same, so I'm just going to copy this and change the wording to top right. And this becomes screen width. To and then we do the bottom viewport. That's pretty much the same as well, so let's just copy this bottom viewport. Start from the left hand corner, and then we go halfway down the screen. That's what this is. Height on 2. And we want to go the full width, not just half. And we want to set this viewport. And we want to render. Okay, and that should be it. We should have success. Let's see what happens. nim. Okay, so we tried and there's a problem. Let's try to resolve this problem. So the problem was with our bottom viewport. So what have I done wrong? So I've set that to 0. I've set the corresponding y value to be height over 2. Set the width to be the full width, and then height over 3. Okay. Right, it's width onto 0, on 2, and then height on 2. Ah, must be because the bottom viewport. Probably need to figure out what's going on. I did get it working previously. So, oh, of course, it's because I just did not set it to the bottom viewport. So now if I rerun this, it should work now. It's a copy and pasting issue. So there we go. This works as expected, and I'm going to call this by the right tutorial number, which is number 9. And then rerun. There we go, tutorial 9. So there we have it. That's what tutorial 9 with changing the viewports is. And let's end it here for now. And then we'll have a quick look at tutorial 10. All right, so we're now up to tutorial 10. Now, tutorial 10 is a bit of a trickier one for a number of reasons, and let's have a look at what we're trying to do first. So tutorial 10, we basically have 2 images. We have an image of a man and a background, so foo and background, and then we want to render them together with some transparency. Okay, so this is the complication here is more nim semantics than anything to do with the actual code. And let's just have a look at the source code and then we'll talk through it. Alright, so I'm going to just call this name. I'll probably screw up when I'm trying to implement this as well, but we'll see how we go. And then I'll probably have to refer to the completed example. So let's go and have a look at, I'm going to copy rectangle rather than previous one. Okay. So the number one difficulty is that there isn't a direct, well, there is a direct comparison, but it's not a line-by-line comparison with C++ when you create a class. All right, you create a class and the associated methods. We do the same thing in nim as well, except that we need to define the getters and setters in a particular way in order to get it to work. And the syntax, I know what it looks like, but I sort of do have to go and look at the references, and it is a bit tedious. Again, it's mostly because I'm not, I don't use nim every day. I'm just using this as an opportunity to learn more about nim. But anyway, let's get started and see how far we get. To start off with, we have the screen width and screen height, so that's pretty standard. And then they go and define what the class is. So maybe for argument's sake, just for clarity, let's do exactly the same thing. So how do we define a class? So firstly, we start with like a struct object sort of thing, where we have texture and this is an object. And I'm hoping I have the format correct. And within this object, if we look at it, there's three fields that we're interested in, and that would be the mTexture, which is a texture pointer. We have mWidth, which is an int. We have mHeight, which is an int. I'm going to have a quick check whether I have the format correct. So type object. I think that's correct. I'm not sure why it's complaining. Well, I'm just gonna. This should work as well. I think this bit is extraneous. It's because I put equals instead of, no, I didn't. Anyway, let's continue on and see whether my IDE will catch up with what's going on. But let's implement the stuff that we know first. So the initialization start with a set hint. Just gonna make this more consistent. So we set hint, create window, renderer, draw color, and then initialize the PNG loading. So that's all the same. Load media. Go to load media, and we want to do a this.load file. So let's try our best. Oops. So gfoo texture, which isn't defined yet, from file. So this would be foo, and then we want to do a background texture load file, and then see what happens. All right, let's go to close. We destroy renderers, destroy window, and quit. All right, so that bit's the same, and then you jump straight into main. So the most important thing is the implementation. But before we do that, let's go and have a look at where this is created. So we have where L texture is defined, and then we need to create gfoo texture, L texture, G background texture, L texture. Okay. And then we're going to initialize. Okay, so that is equal to, oh no. I don't know if this is the best way, but this is I'm just going to do it this way. And we can work through how it will look like. So texture, load from file, we need to define free, render, and get width and height, or a getter and setter. So I'm just going to copy the thing from the getters and setters because it's this tedious code. This is just all of this bit. Okay. These are all the getters and setters for texture, height, and width. Yeah, there's not much to really talk about besides that's how it would operate. Then the next thing we need to implement is like the load from file, free, and render. Okay. So we need to make sure that these actually appear before this as well. Okay. Oh, okay, I see what's happened. Is that the correct order? Equals object. Okay, yeah. Okay, so I need to define a couple of things how to initialize the values. So let's do that as well. So proc init this of L texture M texture inline how do I call this? Right, okay. This will be inline, not initialize. Equals and we just want to go this dot m texture equals m texture. I actually don't think this is how I implemented it originally, but we'll just go with the flow. Okay, so that's how we will initialize. We also need a proc for free. This var L texture what does free do? Goes if not this dot m is nil, right? This dot m texture, then we will destroy this dot m texture, and then I guess we go. Does that work? I actually don't know if this works. I hope this works. And then now we need to call render, or define render, sorry. Proc render, and we have int y int. Initial values, and maybe you can just call it like this. I'm just trying to figure things out. So this is a void and inline. Okay, so we have a rectangle, it's called render quad. And we copy the G renderer. Oh, okay. This.m texture nil and the render quad. It's equal to the rectangle of this dot, no, x dot c int y dot c int this dot m width dot c int this dot m height dot c int render quad. Okay, so that's what render does. And I think this should be everything, right? Well, we're missing a big one, which is the actual load from file. So let's define load from file now. Proc load from file, this L texture, this file. Don't know. And we have path of a string. They've defined this to be a bool. I think this is also inline, I have a feeling. So the first thing they do is they go this.free, and then so new texture is the final texture. Hang on, then why is this bool anyway? Oh, okay, because it's assigned to that. So let's call that okay, and then we have a loaded surface. A surface pointer is equal to SDL2 image dot load of path. And then set color key of the loaded surface. What is SDL true? I think it is. I actually have to look it up. Instead of, yeah, this very weird kind of thing that I would never figure out otherwise. And then we want the map RGB. So in case what you're wondering, what this does is it's going to make the color transparent. It becomes clearer when you look at the two images. So what we want to do actually is we want to put this man in this background, but we want the cyan bit to be transparent. So let's do it. Okay, so and then we want to set the colors, right? So this is dot format, and this is uint80, uint8255, uint8255. So that will be the cyan color, which is the color key. And then we want to set the new texture to be equal to create texture from surface of the G renderer loaded surface. Okay, so I mean that's it. What's this error? Okay. Once this is done, texture is equal to, no. So this should be a var. Well, not sure what's going on, but we'll need to run it anyway, and then we can try to debug. That's part of the fun. Error, invalid indentation. Well, okay, that's a good start. Missing a colon. So of type boolean was never used. So line 93. Okay, well. Alright, so that actually loaded, but I hadn't filled this in, so we got this kind of output, which is kind of useless. I mean, it compiled, sorry. So that's a good start. Let's go and update the main function and hopefully nothing broke. So let's start off by, well, clear screen is the same, as you can see from line 279. Go g background texture dot render 0 0. So we start from the top left hand corner and render blue, and we're going to put g to texture dot render at this particular location. Okay, so right now we get a blank screen. Blank gray screen. Well, it's gray for a number of reasons. One of them is that this is not correct. And the other one is we probably haven't loaded the media that we actually wanted. So let's have a look at where that's loaded. So load media. I don't think we loaded media, right? Yeah. Let's go. Okay, so now we're one step further. We've loaded 2 men, so we probably need to load the correct kind of image. There we go. We've rendered something in the middle, but this looks a bit off. So let me have another look. So when we called the previous one, this is what we should be seeing. But of course, what we got was slightly off. So let's go and have a look at what or maybe speculate why this is wrong. So this looks a bit squished, but I can't really pick out why initially, so I'll probably have to go through everything line by line. Hopefully I'll find it soon, otherwise this video is going to be awfully long. Alright. Here we go. That's why I select it to be a rectangle, a square, sorry. So now if I rerun this, it should work. This is a small careless error. And there we have it. That's the same as the tutorial 10. So this just shows you how we can pull all of these things together. So to recap, to do something object orientated like in the scheme of nim, you would do, well, you define the struct object if you like, and then you define the various procedures to run over that object. Or you can, I think in the original implementation I used, I also played around with methods, but this way it would work fine as well. So this is just one way of how we can do something object orientated. Right, so these are all the associated methods, even though I've called them procedures. Nim does have methods, and maybe at a later stage I'll revisit this and rewrite them as methods, rather than what I've done here. Yeah, so this is all there is, and we're now up to number 10, and hopefully soon we'll also look at number 20.